LuxMed CO₂ incubators are essential laboratory equipment used to maintain optimal conditions for cell and tissue cultures. They provide a controlled environment with specific temperature, humidity, and CO₂ levels to promote cell growth and survival. These incubators are crucial in various applications, including cell-based research, drug discovery, and even in vitro fertilization. Uses of CO₂ incubators. Cell culture. CO₂ incubators provide a stable and sterile environment for growing cells, ensuring optimal conditions for cell growth and differentiation. In vitro fertilization, IVF, they're used to cultivate and maintain embryos during IVF, providing the right environment for embryo development. Drug discovery and development. CO₂ incubators are used in drug testing and the development of new medications, as they allow for controlled cell culture conditions for drug screening. Tissue engineering. They are utilized in the development of tissue-engineered products, such as 3D cell structures for grafting or tissue repair. Research and development. CO₂ incubators are widely used in various research fields, including immunology, oncology, and cell dynamics. Vaccine and antibody production. They play a role in the production of cell-based products like vaccines and antibodies, which are crucial in the pharmaceutical industry. Diagnostics. CO₂ incubators are used for diagnostics, such as cell-based assays and monitoring cell growth in various applications. How CO₂ incubators work. CO₂ incubators control several key parameters to maintain optimal conditions for cell culture. Temperature. They maintain a specific temperature, typically 37 degrees Celsius, which is optimal for many mammalian cell types. Humidity. High humidity levels, around 95%, are maintained to prevent the cells from drying out. CO₂ levels. The CO₂ concentration is carefully regulated, usually around 5%, to maintain the pH of the culture medium. CO₂ interacts with sodium bicarbonate in the culture medium to buffer the pH within the physiological range. Sterility. They are designed to prevent contamination by filtering the air and water used in the incubator, as well as providing a sterile environment for the cells to grow. CO₂ incubators are designed to create and maintain controlled environments for cell culture, primarily focusing on temperature, humidity, and CO₂ levels. These incubators use a closed system to regulate the atmosphere inside the chamber, ensuring optimal conditions for cell growth. Here's a more detailed breakdown of the key design principles. 1. Temperature control. Heating systems. CO₂ incubators typically use either a water or oil jacket, or electrical heating elements to maintain a constant temperature, usually around 37 degrees Celsius. Precision and uniformity. The design aims for precise temperature control and uniformity throughout the chamber to avoid thermal gradients that could affect cell growth. 2. Humidity control. Evaporation and condensation. Humidity is maintained through a combination of evaporation from a water reservoir or atomizer system and condensation control. Constant levels. The goal is to maintain a high humidity level, typically around 95%, to prevent media from drying out and to ensure proper cell hydration. Three. CO₂ level regulation. Sealed system. The incubator's design features a sealed chamber to isolate the internal environment from external CO₂ fluctuations. CO₂ supply and control. A CO₂ gas supply, often with a built-in control system, ensures that the CO₂ concentration within the chamber is maintained at the desired level, usually around 5% for many cell cultures. manufacturing partner for inline country that produces goods for local demands and supply to reduce manufacturing costs or access specialized capabilities and technology access to scale global business operation. For details, please revert.